This is P.7 day 3, solving equations, quadratic equations. All right, number 1, solving by factoring. Well, you know how to factor a polynomial. For example, this one, we just factor out the 3 and an x, and we get x minus 3. So now we use something called the zero product rule. We have something times something equals 0. Then we can figure out what x could be, because the first term could be a 0 or the second term could be a 0. So here we would divide by 3 on both sides, and 0 divided by 3 is 0. This one we would add 3 on both sides, and x equals positive 3. So I have two answers here. X could be a 0 or it could be a positive 3. Now, notice how number 2 is different than number 1. This one only has 2 terms. The last one is a 0 value. This one has 3. This is a quadratic. So what I want to do is I want to get all the terms together on one side. So I'm going to move the 1 over there by subtracting it on both sides. And I get everything set equal to 0. That's one of our main objectives, is setting things equal to 0. So I'm going to want to now factor, if I can. Obviously 2x squared comes from 2x times x, and negative 1 comes from negative 1 times positive 1. If I put the negative 1 here and the positive 1 there, it works out, because if I FOIL this together, the outside ones would be positive 2x and the inside would be negative 1x, and when I add those two together I get positive 1. So now again, the zero product rule comes into play. I have something times something equals 0. So I will set each one of those separately equal to 0 and solve. Don't forget that when you get a fraction, keep it in fractional form. Do not convert it to a decimal. So my answer here is, whoops, I forgot to add. There we go. Positive 1/2. Copy error, my bad. And then the other one would be negative 1. So positive 1/2, not 0.5. Another type of solving would be as if we have something like this. Now this looks very similar to what we had here, right? But we do it very differently. Here you can factor some things out, whereas here, not exactly. There's actually a little faster way to do this, so I'm just going to show you another method here. If I have a constant here, the fastest way to do it is actually to move it to the other side. And then divide by 3. And then take the square root of both sides. Don't forget, when we go from a regular number to putting a square root on top of that, that's when we have to remember to use our plus or minus. So I get x equals plus or minus the square root of 7. So what I basically did there is I isolated the part that had the x squared in it, and then I was able to get the square root of that to cancel that out. That's called isolating the square. Once you have something squared, you can take the square root of both sides, right? So that's what I have on number 4. I have something that's squared. So right away, I know that if the only thing on this side is squared, I can take the square root of both sides. Don't forget, on the 11, you turned it from a regular 11 to the square root of 11, so that's when we use our plus or minus. On this side, the square and the square root cancel, and I just get x plus 5. Keep your plus or minus, because now we're going to solve for x by subtracting 5 on both sides, and we get x equals negative 5 plus or minus the square root of 11. Now, another type of equation that we could have that uses squares is a regular trinomial like this. Here's the quadratic formula in case you don't remember. Solving this by the quadratic formula, we have to have everything on one side and then 0 on the other. We cannot have everything kind of half and half, some terms on one side and some terms on the other. Everything has to be together. Then we can start using the quadratic formula. A is 2, B is also 2, and C is negative 1. So as I start placing these values, negative b plus or minus the square root of b squared minus 4 times a times c all over, don't forget this bar goes all the way underneath everything, not just one part, 2 times a. All right, well, simplifying, we get negative 2, that's negative, not positive, plus or minus square root of 4 plus 8, because that's negative 4 times 2 times negative 1 is positive 8, so it's plus now, over 2. So I have negative 2 plus or minus the square root of 12 over 2. Now the square root of 12 can be factored into the square root of 4 and the square root of 3. And the square root of 4 is 2. Now, here's the most important part. Whoops, that's a 4. Oop, copying error, my bad. Sorry, guys. These are 4s down here. Oh. It's the second copying error. My God. Nah. Okay, so it's supposed to be a 4 down here. Underneath everything. There we go. Alright. So now, here's the most important part. What you want to do is rewrite this fraction as 2 parts. Okay? So, if I have negative 2/4 plus or minus 2 root 3 over 4, that's the same thing as this, believe it or not. Okay? And if I reduce the first fraction, I get negative 1/2, and the second one would be square root of 3 over 2. So you can leave your answer like this, or you can put it back together as negative 1 plus or minus the square root of 3 over 2. Now, the last thing I want to show you is how to find something called the discriminant. You've seen it before. It simply tells you how many answers and what kind you have. So the discriminant is this. It's b squared minus 4ac. And if that number is greater than 0, then there are 2 real number solutions. If that number is equal to 0, there is 1 real number solution. And if that number is less than 0, then there are no real number solutions. So let's compute the discriminant for this. Remember, as a quadratic, in order to use the quadratic formula, you have to have everything on one side and then equals 0 on the other. Then a is 3, b is negative 2, and c is 5. So the discriminant, b squared minus 4ac, becomes negative 2 squared minus 4 times 3 times 5. So that's 4 minus 60, which is negative 56. Negative 56 is less than 0. So we have no real number solutions. If this had been a positive, then there would have been 2 real number solutions. And if this had been equal to 0, then there would have been 1 real number solution.